With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with the question which says calculate the equivalent focal length of a plano convex lens for the following cases. First, when curved surface is silvered, and second, when plane surface is silvered. So let's take each case one by one. So first case we can see, let's try to analyze the given situation over here. So this is a plano convex lens, and of which a curved surface is silvered, as we can see. So we have this is a case of silvering of a lens which we have already covered in the theory class. So we know the whole of the system behaves as if it is a mirror. Alright, so this is nothing but it is the reflection or the refraction of light takes place as if it is a form of a mirror. Alright, so we can see over here, this is a plano convex lens and this is a concave mirror over here. When we separate both of this, so the equivalent, to calculate the equivalent focal length, first we will calculate the power. So power equivalent can be written as, first as we can see, the light will enter the plano, or the ray will enter the plano convex lens, then it will go to the mirror, and then again it will come back to the convex lens, and then it will come out. Alright, so we can write, first it will go into the lens, plus then it will go into the mirror, plus then it will come out of the lens. So these are all the equivalent power we are getting, and we know the whole of the system as if it is behaving as if it is a mirror. So we know power for a mirror is nothing but it is negative of reciprocal of focal length. So we will write it as 1 over f equivalent. For mirror it is negative of 1 by f, and for lens it is plus of 1 by f. So we can write it as 1 by fl. Again we can see it is a mirror, so we will take it as minus 1 by fm, and here it can be written as plus of 1 by fl. Alright, so let's say this is our equation number 1. Alright, so first we will calculate fl, fm, and then we will substitute in this equation and we will get the desired result. Let's suppose that this curved surface of the lens is having a radius of r. So we can write, for mirror we know focal length is nothing but it is negative of r by 2. Why we are taking it as negative? Because the mirror is concave mirror, and we know for concave mirror focal length is taken to be as negative. Alright, so this is our equation, let's say second. And for now we have to calculate focal length of lens. For that we will use lens maker formula. By lens maker formula, so now we can say by lens maker formula, which is nothing but 1 over fl, and that is equals to mu minus 1 into 1 over first radius of first refracting surface, that is when the light is coming this way, so it will first get refracted by the plane surface. So plane surface has a radius of infinity, so we can write 1 over infinity minus of 1 over 1 by minus r. Now after getting refracted from here, so it will incident on the curved surface of the lens. So when it gets curved surface, so curved surface radius is, we have supposed it has to be r, and it is measured in the leftward direction, which is opposite to incident light, so it has to be taken as negative. Just we are following the convention, so it comes out to be mu minus 1 by r. Therefore from here we can say the value of fl comes out to be r by mu minus 1. Alright, so we have calculated the values of focal length of lens and mirror from 2 and 3. Now we will substitute the value of 2 and 3 in equation 1. So we can write, from equation 1, minus 1 over fe will be equals to 1 over fl, that is mu minus 1 by r. So we can directly substitute it as mu minus 1 over r minus of minus, so this will become plus 2 by r, and finally plus of mu minus 1 by r. This can be written as further, minus 1 by fe will be equals to mu minus 1 plus 2 plus mu minus 1 dividing by r. Alright, so from here we can clearly see minus 2, this will get cancelled out, and final result we are getting is 2 mu by r. Therefore the value of f equivalent can be written as minus of r by 2 mu. Alright, as we can see, the result of focal length equivalent we are getting is negative, and so we have also seen that the whole of the system was behaving as if it is a concave mirror. So, and for concave mirror, focal length has to be negative. Alright, so now let's move on to the second part. So for second part we can say, so its condition can be written as, now let's try to visualize this condition. So now plane surface is been silvered. So for that we can again see, we can say power equivalent we will again calculate, and now the whole of the system is again behaving as if it is a mirror. Alright, so we can first write power equivalent, that can be written as, first it will, the light will go through the lens, that is PL, and then mirror, and then finally it will go to again lens. Alright, so from here we can say this can be written as, in terms of focal length we can write 1 over Fe, that is negative because whole of the system is behaving as if it is a mirror, and for mirror power is nothing but it is negative of 1 over focal length. So this can be written as 1 over Fl plus of, here it will become negative because power is minus time of 1 by F mirror. Alright, and finally we have 1 over Fl. Let's say this is our equation number 1 for this case. Alright, now again we can say for Fm we can write Fm, that is focal length for a mirror, that is, here we can see this is our lens and this is our mirror. So for mirror focal length is, we can say it has to be, if we substitute it as r by 2, r for focal length for a plane mirror is infinity, so this value comes out to be infinity. Alright, so let's say this is our equation number 2. So now it's time to calculate focal length for a lens. So we can write by lens maker formula, by lens maker formula, as we can see, lens maker formula says 1 over Fl will be equals to mu minus 1 into the first refracting surface, that is when the light is incident, the first refracting surface is the curved surface and its radius is in the direction of the incident light, so it has to be taken as positive, and we are assuming that its radius is r. Alright, so from here we can get the result as 1 over r minus 1 over, for plane surface the radius is infinity, so the result we are getting is mu minus 1 by r. So this is what the value of 1 over Fl we are getting. Alright, and now let's move on. So from equation, let's say this is our equation number 3. If we substitute 2 and 3 in 1, we can get, therefore from equation 1, minus 1 over Fe will be equals to 1 over Fl, that is we have calculated it as mu minus 1 over r, and here it can be written as plus of, or we can write it as negative of 1 over infinity will be nothing but, it can be written as 0. Alright, and finally we can say plus of mu minus 1 over r, and if we solve this value we can get minus 1 over Fe can be written as mu minus 1 plus mu minus 1 dividing it by r. So from here we can say the result can be written as 2 mu minus 2 divided by r. Alright, so if we solve it further, therefore the value of focal length equivalent can be written as r minus r over 2 can be taken out as common upon minus r over 2 mu minus 1. So this is the focal length equivalent for the next case, for this case we are getting. So again we can see the focal length is coming out to be negative, so the whole of the system will behave as if it is a concave mirror. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.